My name is John Sankovich. I'm Vice President of Cloud Solutions with ECS. Appreciate everyone coming out. Excited to talk about machine learning, in particular the SageMaker platform within AWS. We've been highlighting this in our booth the last couple days, and to be honest, the excitement and the interest and the questions were almost overwhelming. So we think it's a great topic. Hopefully you'll find some value in it. At a high level, we wanted to, Ross Serino is our Director of Cloud Transformation and has been leading a lot of our machine learning. And I found it really interesting when I'm talking with Ross as he explains things. And I say, oh, it's kind of demystifying machine learning, for me at least. And then specifically, I'd never seen a SageMaker notebook. And so walking through that, I really got a lot of value out of it. So as we were talking about different ideas, this seemed like a really good one because, to be honest, I got value out of it. So hopefully you'll see that same interest in it as we go through. Sorry. So our agenda overall, we're just going to review what we're hearing as customer challenges. We have a very diverse customer base across public sector, commercial, state and local, DoD, intel agencies. So we're seeing and hearing things, and we thought it'd be useful to just summarize those a little bit so that we can kind of then set up how we're approaching that, and specifically how the AWS platform approaches it. The machine learning, we have John Calhoun here, who's an expert in the AWS platform. He's going to walk through some of that. We're going to talk a little bit about a platform we developed, and then how we've integrated machine learning, because we thought that was really valuable for a couple different reasons. Then a little bit more about some specific use cases. We're going to show an actual, we PDF'd it to make it a little simpler, but of a notebook, just in case if people haven't seen that before, and Ross is going to walk through that. And then some value benefits and lessons learned. So it's kind of a full agenda, but we thought it was useful, and we'll go through it as best we can. Real quick, want to just give a little overview on ECS. We're leading AWS Partner and really focused since around 2010 on the AWS ecosystem. As part of that, we also do a lot of cybersecurity. We are local in the Fairfax area, around 600 million in revenue and a couple thousand employees. And basically, that's just a little background so you know kind of who we are. I'm going to build the slide out. Mentioned a little bit, we've been an AWS partner for quite a while. It is great to see how this summit has evolved. Teresa Carlson mentioned when we first did it, there was like 50 people in Arlington in a room, and now I think there's 14,000. So it's really great to have been part of that and to see it develop. We are a premier consulting partner, also an audited MSP, which is a really, really great program AWS has developed. We've been in that program for 5 years. And so what we find is a lot of customers, as they go through this cloud adoption lifecycle, it starts with consulting, and then it quickly goes to managed services as they focus on their mission, and we kind of focus on the rest. We did get the ML competency. Imran's going to highlight that just a little bit. I think there's 17 or 20 or so companies in the world that have that. So there was a lot of focus for us, and Ross led a lot of that effort. And then some of the other competencies, DevOps, Microsoft, government competencies. We are a big public sector partner. And then also GovCloud, which is a very important part of a lot of the platform for a lot of our customers. So that's just a kind of a general overview. I'm going to turn it over to Imran, and he's going to talk a little bit about the machine learning competency and how that program develops, and for your own kind of background.
Thank you, John. Good afternoon, everyone. So for any of the people, if you have ever been involved in AWS Competency Program or a review of that or in preparation of that, you can understand how involved that process is. And ECS, right from the beginning, as a strategic objective, one of the things that we wanted to do was that we wanted to stay ahead of the curve in terms of AWS competencies. So last year when AWS mentioned their machine learning competency, we were the first ones to raise our hands and say, absolutely, this is something that we have been looking forward to based on what our customers have been asking. We were anticipating the needs for our customer based on the questions and their requirements. And so we went through that process. Our excellent technical team, the depth of our technical team, it requires a lot of AWS, a wide range of AWS certifications, the customer workloads, and the solutions that we have developed as using AWS's machine learning and other machine learning techniques. It was a perfect alignment with the machine learning competency. And as John mentioned, that resulted in us getting that competency very quickly, and we are very proud to have that. And it not only shows our commitment to keeping in pace with AWS innovation, but also validates to our customers that we have the required skills, the experience, solutions, and the technical depth to help them with their machine learning workloads. So speaking of customer challenges, so I think one of the most common themes that we have heard from our customer is about comments about their cost at the end of the month. And some of those questions that come up is that, oh, my bill is a little higher than I had anticipated. I was thinking 8 cents an hour for my T1 micro or whatever that case may be. But this is like $170 or whatever, right? So what is that? Why is that my bill so high? What are the services that I'm using that contribute towards my bill? Are there any consistent patterns that I can see? Can I look at predict, or if you are doing financial planning, especially for government purposes, they want to look at things in a more budgeted fashion and say, what is going to be the cost over the next year or 3 years, whatever your BPAs or contracts period of performance may be. So all of these things contribute towards an unpredictability of their budgets, the spending patterns, and if there are any anomalies in your spend. And I remember one time, one of our guys started an M4X large instance, okay? And they'd had our suite deployed on that, right? He meant to use it for 3 hours, do a demo, and turn it off. Guess what? He forgot to turn it off. And 1 month later, there was a $1,200 bill for that unintended use of that particular instance. So those type of anomalies, that can I catch it early enough? So two things. Can I do a more predictable bill? And second, are there any anomalies in my bill and spending pattern that I can catch early enough to prevent any of those costs from rising up? So those are some of the things that we focused on that hearing from our customers. So how do we solve those challenges is the next question. Let me just look at a general trend of how we use cloud, right? Generally, we start using cloud, we add more services, workloads to that, and then do some kind of a transformation to adjust it. And then as we increase our usage of cloud and our spending pattern and our cloud utilization patterns, we start to get some insights, right? I tend to be more on US East using M5 instances versus a small portion is RDS and so on. And then based on those utilization patterns, I can adjust my cloud governance strategies. Where do I spend my time? Where do I spend my resources, trainings, and all that to have it in a more controlled framework type of a fashion? And once I get that, that gives me enough data to say, how can I optimize my environment? How can I provide some cost savings? How can I do performance and security optimizations in my environment? So what we have done is that we have taken all of that data as we saw across multiple customers. And for each customer, we looked at that data, enhanced that data with their cloud utilization patterns, and then say, how can leveraging both of these spending and utilization patterns, can we help customers in predicting their bills over a long period of time? And Ross is going to speak more about how we have enhanced that data and how we leverage it, AWS native services like Athena and SageMaker as they have evolved. We will be speaking more about that. And then the second step is that when those, are there any anomalies that I can detect early enough that would help me prevent any of the costs that I would see at the end of the month? So it increases our predictability as well as it reduces any inadvertent use of cloud for us. So we're going to before Ross speaks, I'm going to ask John Calhoun to come and speak, give you a little bit more about information about the AWS machine learning services, and then Ross will take how we implemented that using those native services. Thank you very much, Carl.
Thank you. So I'm John Calhoun. I am a solutions architect here at AWS on our public sector partners team. And I work with many of our partners like ECS, and it's really exciting for me to see the kind of things they're doing. It's really exciting to see how, see our services, but then see how ECS is using this to solve new problems, to improve their business, to help their customers. And a lot of this comes out, at AWS, we are customer obsessed. So in the machine learning perspective, we are listening to our customers and asking, what is it they need? How can we empower them to innovate, to do machine learning, to solve their problems? So we're going to start off with sort of a 10,000-foot overview of machine learning on AWS, and then we're going to work down to specifics and then finally dig into exactly the really cool stuff that ECS has done. So machine learning at AWS, it's really a variety of things. So we'll start at the bottom there. So, hardware. So one of the things you need to have to do machine learning is you need computing power. And there's not a single type of computing power you need. You need big, strong GPUs to do neural network processing. You need big general compute to design and build the machine learning. And even more and more customers are using FPGAs on our F1 instances to do super low latency inferencing. So we provide that variety of hardware for customers to do that. On top of the hardware is software. There's a lot of different frameworks and tools out there for customers to use. We have MXNet, we have Caffe Torch, TensorFlow. We have all that packaged into an AMI. So we have an AMI customers can run on an EC2 instance of their choice. And this AMI already has all the stuff they need pre-installed. It already has NVIDIA drivers pre-installed. Again, getting them faster. And then on top of the hardware and software, we have these application services. So this is machine learning in a box, ready to go. So services like Poly, lifelike human transcription of text to voice, done in a believable, on-demand, scalable way. Services like Comprehend, the ability to scan and analyze, millions of lines of text and understand what people are doing. Again, things like this, like Comprehend, allows customers to understand, how are people tweeting about them without having to go into the details of machine learning. Services like Lex allow customers to build chatbots without having to know all the little details of natural language processing. And then a service we announced at re:Invent, SageMaker, is especially exciting. So SageMaker ties together the software component of machine learning, the hardware component of machine learning, and allows customers to deploy machine learning the same way we build our application services. Allows you to put a machine learning model behind a REST endpoint. So again, a super exciting way. So it allows you to scale up, to do massive training, and then scale all that down when you're done training. It puts instances behind a load balancer, behind your endpoint to do the inferencing on. It allows you to control the entire workflow to make that happen. And again, it's really exciting to see how ECS has leveraged incredibly quickly ECS to build out some really cool services and applications. A couple fun, really cool things about SageMaker is it's another example of sort of the breadth of things you can do. So at a low level, it's this sort of machine learning workflow you can work with. But it also comes with pre-baked algorithms. So it allows you to really quickly do image classification, do sort of regression, to do other types of classification really, really quickly without having to dive in and build a lot of code. Part of it is our hosted Jupyter notebooks. So again, it's going to be really cool to see ECS show you, how they've leveraged those notebooks to build and control and develop these applications. So I'm going to invite Ross up here to talk to y'all further. Thank you.
Thank you very much. Thank you, John. Thank you, Imran. What I would like to really talk about now is a platform that I've been working on with my team for a number of years. We started the initiative about 5 or 6 years ago because when we looked out in the market, we needed, the original use case was a tool to help our billing department manage Amazon bills better. And as we started running multiple master payer accounts for our customers, we needed some way of aggregating all of that data into a consolidated view for us to use for just a lot of different purposes. So the current name of the platform, it's been through a few iterations, is now CAMP. It is our cloud automated management platform. And what's really exciting about this is we started off with I'd call it a traditional application. So, myself, I was a .NET architect as well as a PHP architect a number of years ago, and a lot of my team members were .NET architects as well. So we built a system that was originally a WPF Windows application that had an access key and a secret key compiled in it, and it listed your billing files in S3. And we gave that to our finance team, and they could download the files and look at the detailed bills because they needed to get down to the resource level for some of our contracts. Well, shipping builds wasn't really working, so we turned it into a web-based application, and we started loading all of this data into SQL Server. Then we put a nice front end in front of it, and then AWS came out with Cost Explorer. And we went, oh, well, they kind of did that better than us. But Cost Explorer can only look at one organization currently. So when we need that multi-master payer account view, we still have a limitation on the AWS platform. But that's not to say that's not going to come in the future. So we've decided to really embrace AWS and bring all of that innovation in. But at a core, what we're looking at is dimensions of data that we get on any customer that we support on their bill, such as the AWS service that was used, the region, the availability zone, the account, the tags, those types of metadata that'll be available no matter what you're doing in AWS. And originally, we were leveraging statistical analysis, but in very recent years, we've been integrating these ML algorithms into how we support our customers. What we look at is not just a single dimension, but those multiple dimensions that I was calling out for us to have a better understanding of what our customers are spending. We want to know, is this anomalous within this customer compared to our other customers? We want to know, is there regions that are being used that we wouldn't expect to be used by, say, government customers? And all of this is leveraging data that's available just by going into the cloud. So if you're in the cloud, this data starts getting generated because it's your bill. And there's very detailed granularity that goes down to the actual every hour of billing, and you can learn on that data. So what we do is we bring all of this data into S3 at the end of the day. And kind of the kicker here is prior to being in cloud, I was doing a lot of work with the Department of Defense. And we were in the process of getting rid of CSV files that were being used to transmit data between systems and move them into databases and web services. Now, what I'm doing is mostly getting data out of databases back into CSV files so that I can get it into S3. Because if I can get data that is structured into S3, I can front it with Athena. And if people here haven't used Athena, it's immensely powerful as a completely serverless managed service to run very large SQL-based queries across immense data sets. So we just throw more data in S3, and we get more results out of Athena. And we're able to query trends over the last 5 years for all of our customers. And it turns out that this ends up being really, really good data for training as well. And that's why we've decided to highlight this use case as I'm going to walk through these in more detail. Here's a little architecture diagram just to show you we don't really think about servers anymore. We're in the process of modernizing all of our platforms, and we've just stopped thinking about servers. It's just not something we worry about anymore. We have data somewhere, and we have various mechanisms of either getting that out of a database and into something else, and just various tools that we've developed or worked with different integration providers to get data into a consolidated format. And if you can get that data into S3, you can put Athena in front of it, as I was mentioning earlier. And if you can start querying your data with Athena, you can begin making slices of that data to train in different ways. Maybe you only want to look at a specific region to know how those trends worked over time. Maybe we want to train a model with all of our customers' data. Maybe we want to make a model for a specific customer. If all of this data is available in a data warehouse, you're empowered to make those decisions of what you would like to see, what you would like to visualize. And then at the end of the day, we really want to emphasize this cloud governance piece, because you can have all the data in the world. You can have all the dashboards you can imagine. But if there's not a process in place to do something with the data, you're not really going to get anywhere. But in terms of doing things with the data or looking at the data, Amazon SageMaker has really been a differentiator for us to just make this easy. And that's kind of what we're seeing with AWS. Just if we do something or if our customers are doing something, how do we make it easy? How do we make it seamless? And how do we go serverless? Because that is what we see as kind of the future as we've been developing our own in-house tools, is embracing this concept of serverless, embracing this concept of data flows, and how do we get insights into all of this data that we have. Some of the use cases that we wanted to highlight just briefly are predictive spend. So we often get asked for customers, what will my cost be over time? And if I make decision A, B, or C, will that end up being better in the long run? And with this specific example, we use our technology to make reserved instance recommendations. And we've seen over $10 million in reserved instance purchases that we've made recommendations for based on our platform. We've increased accuracy of how we're forecasting where cost trends are going, because we can look at things like seasonality with machine learning-enabled algorithms as compared to just relying on big trends from statistical algorithms. And we are also using this data to say, here's where you are in AWS, not just from a footprint perspective of resources, but total cost by region, by trend, and it's just that data that we're able to then answer the questions that our customers ask us. Because what we found is our customers ask us very specific questions about their workloads. They want to know, what is your recommendation for reserved instances? And if you use, say, the Amazon tool, which does work great, it'll give you a recommendation for that whole pool of resources. But sometimes customers say, well, I just have this one product that's in these 4 accounts. What should I buy for reserved instances? And that's where having that data in Athena and being able to create that slice to then just run the analysis on that data really comes into play. The next challenge that we hear a lot about that we want to talk about as a use case was anomaly detection. The screenshot that we showed earlier of the $51 million cost was the first anomaly that we detected with IRAMP. And it turns out that there was actually just a rounding issue for 1 day of billing data in GovCloud with a new service that was released for, I think, custom CloudWatch metrics. But we got the alert that morning, and it said, usually our daily cost was, I don't know, a couple $100,000. But it was $51 million for just that day. And we didn't need machine learning to know something was up. And originally, we thought it was a bug in our platform. And we were like, oh, surely we made a mistake. So we logged into Cost Explorer, and we confirmed, oh, no, Cost Explorer is seeing the same thing. Emailed AWS, and they said, oh, decimal place was off. It'll be fixed tomorrow. And it was just just a simple error. But had that not been something, we quickly realized, it's very important we look at this every day. It's very important that we understand how these trends are going. So at a minimum, we'll track a 7-day moving average across all of our clients for all of their accounts to know if there's just a 7-day statistical anomaly occurring. But the solution here is to really enhance that by adding that anomaly detection, not just for is my cost for this day or anything like that normal, but if I'm spending $1 million on RDS, am I the only customer that's doing that? And that was the specific use case here, where we were able to confirm by looking at all of our data, by looking at our analytics, that based on the workloads that this customer was running, that did seem like an appropriate purchase based on what we're seeing from other customers. All right, let's look at some code. So if people here haven't seen Amazon SageMaker, this is a Jupyter notebook. So SageMaker is made up of multiple components, but the real heart of where you're going to do all your work in SageMaker is within this notebook technology. So Jupyter notebooks are just a Python-based technology that's out there, but SageMaker has made it very, very pretty and very, very easy. And I know we talked a little bit earlier about all these different components of SageMaker, but SageMaker also includes a Python library, which I want to just emphasize that it makes all of this really, really easy. So if you've never used SageMaker before and you have an AWS account, I recommend going in and creating the smallest notebook possible and just look at all of the examples that are there. So Amazon's been publishing examples into SageMaker that all you have to do is create a notebook. And you can run on like a T2 small for this initial test because your notebook's not going to do any of the heavy lifting. And this structure of a notebook is just a very common way that we approach problems. So just to start scrolling through this, and this is actually a static PDF, but if I had this up on the web, it would be live, and I could hit Shift-Enter to run these commands. And what you see here is actually Markdown, like you would do for like GitHub and things like that supports just text. And then this is Python code that you can actually execute. And it's running on a technology called Anaconda that allows you to manage all of your dependencies and multiple environments. So when we say earlier that SageMaker supports Apache MNextNet and Gluon as compared to TensorFlow, those are actually just different Anaconda kernels that you can get a terminal to if you need to. So all the same things that you would do with Python code are available to you here in a Jupyter notebook. OK, so to walk through the way that we like to approach or like to explain how to leverage machine learning is first run your setup and then get data. So in this example, I ran a Athena query across all of our accounts to get all charges that were not reserved instances or support costs. And I excluded those because if you include reserved instances, it'll be a different type of analysis because you have to choose if you look at the spike or if you blend it. And then with the support charges, you have a similar question. But for just detecting what that overall trend is or what you should expect on your bill, we're able to use this data set. So let's start off with a visualization of the data. So if you can visualize your data, you can have a conversation. Because if just we look at this chart, we can start saying things about it. Overall costs costs have gone up over time, but something happened, we don't really know what, and it moves up and down a lot. And this is the type of shape that we started looking at to say, OK, we need to use machine learning. When we first started working with customers in AWS, we were running very static workloads. So all the lines looked like this. And if you have a flat line or a line like this, you don't really need machine learning because it's just a line. But as soon as your data starts going like this, machine learning will help you fit that curve. So what we do is, given a data set, you have to decide how much of that data set you're going to use for training of your model, how much of that data you're going to use for validation of your model, and then the final piece is how do you then run predictions against your model. So with this example, we do a 60-20-20 split. 60% for training, 20% for validation, and then we'll run prediction against that final 20% of data. What this code is doing is just bringing in that CSV using the Python pandas library, and then we're splitting it out into multiple components, and then we're going to be using that data to then train with SageMaker. One final thing that I wanted to show is just this line of code, which is a SageMaker function that will convert your data that you have in memory or in Python to a machine-readable format. And if anybody's ever tried to work with protobuf or record.io or any of those types of technologies, they make very ugly files. So CSV files, you can open it up and you can see if it looks good. But these other formats that are designed to optimize machine learning are really ugly. So these SageMaker libraries just make it really easy to take things from one format to another. All right, now we start training. So to invoke a training job in SageMaker, you just call SageMaker. So that Python library that I mentioned for SageMaker is allowing you to write in your Jupyter notebook, invoke the other component of SageMaker, which is train, to start a, in this example, C4 extra large instance to then run our training job. And that training job will have a big, long output for each iteration based on how many batch sizes I performed and what other hyperparameters I specified. And the beauty here is you can run this as many times as you need to, tweaking these hyperparameters. You know, should I be using absolute loss, or should I be using the default behavior of the linear learner regressor model? Try both. Run them in parallel. It's fine. And that's really the beauty of what SageMaker is providing. That's the differentiator, is you can run all of these ideas you have in parallel and not worry about being bottlenecked by hardware. So with this sample data set, this whole training job only takes about 5 minutes. So then after you have a trained model, you'll see that in the SageMaker UI, then you host an endpoint to actually run prediction against. OK. So we did all of that, but we haven't really done anything. We just invoked some commands in SageMaker, and it did some stuff. But what did it really do? So now we start making our actual predictions based on that data. And there's some details around all of these different types of prediction models that you can use, but I won't go too far into that here. But if we didn't use our model and we just made a naive prediction based on the data, we get something that's just wildly off. So we're going to ignore this naive analysis where the actual data is the blue line, and this kind of naive, just guessing, if you will, without using our prediction, is nowhere close. But now that we actually start to use our prediction model, we're able to either, there's a few different ways to go, but this is called a one-step ahead MDAPE. And now we're starting to see a line of prediction that's actually starting to match our data. And this is when things get really interesting, because you can see how well this is working. And you can compute how far your error is and then kind of compute that like a confidence interval to then look at, should you trust this model for prediction? And what's key here is the orange line is entirely out of an ML prediction. And the blue line is the actual data of that final 20%. So if we go back up to our original picture, that final 20% is just this box right here. So it knew, based on that trend that it saw, what that shape of data would look like. And we just want to emphasize how powerful that is, because we're beginning to then say, we should consider what this model outputs. So now we can look at 7-day moving average of cost, as well as ML predicted cost. So now we can say, oh, there's a data anomaly for this day, and it's because it's statistically an anomaly. But it may say it's not an ML anomaly, so don't alert. And that's really where that governance strategy comes in of, do you assign a resource to go look at this issue? Comes in. And if you're just constantly chasing false positives because it's natural for your workloads to be spiky, maybe on Saturday and Sunday your workloads are lower as compared to Monday through Friday, ML models will start to pick that up. One other type of analysis we did was multi-step, and that's just a way of making the prediction in steps. But the key here is no matter what type of prediction you start running, if you can visualize it and compare what your actual error rate is or your confidence on real data, which is called evaluating ground truth, you can constantly refine these models by following this process to get better and better data and better prediction. And if you can build this into an overall governance process, now you can actually make changes and then verify that those things that you're doing are making you come in under your projected cost. So it really needs to be a conversation around all of these aspects, but machine learning just empowers things in a new way. And it's not necessarily that it's new technology, it's just available to everybody now. And then the final piece of this notebook is I did try to run a statistical analysis on the data set, and I ended up creating a 6-degree polynomial trend line, and the dashed line is that trend. And the idea here is if you were just trying to look at, is my cost next year going to be roughly higher than last year, a statistical model can give you that curve, but it doesn't try to fit the curve. And that's really the difference when we focus on machine learning algorithms with time series data. And then the final line up here is it cleans up the endpoint. This whole thing, had I run it, would have run in 15 minutes and cost a few dollars. Just immensely powerful. Can we switch? Just to emphasize, if there's one thing to take away from that Jupyter notebook, it's if your data looks like this, use machine learning. So now I want to get to, what are the actual values and benefits that our customers get by working with us, by using our tools, by using our platform. And it's really, you can get a lot of data out of data you have already. So whether it's your bill, whether it's your ticketing system, whether it's CloudWatch, there's just all kinds of things that you can bring in and start learning on. I didn't highlight it, but we do ticket analysis with AWS Comprehend to know what people are asking for through the support system that maybe wasn't categorized correctly. And if you can get all of these dimensions together, you can really start getting a multi-dimensional analysis across your data. And that's whether you're doing just time series predictions or if you're trying to do other deep learning to then make educated decisions to drive your business. It's very, very important to have a governance model in place because when an alarm goes off that there's an anomaly, if you don't have a process in place for somebody to do something about it, then the alarm was of no value. And there's been too many times that I've just seen dashboards with hundreds of alarms, and you say, there's all these alarms. Isn't everything down? No, that's normal. If there's 115 alarms, then there's a problem. Let's clean that up. Let's put a governance model in place that there's no alarms so that if there's a red light on, we're looking at it and we know it's a problem. And we can get confidence that we should look into things with these ML predictions. Do also want to emphasize the serverless benefit, and really it's going to come in not just with cost, but also with scale. Because if you're using serverless technologies that are designed to scale, you don't really think about things the same way anymore. And what I mean by that is we just throw data into S3, and then we write SQL, and we get results. And originally we were blown away by Athena, but just accept it and use it as a tool. And it's very, very powerful. And by combining all of these AWS services, you're able to then get those outcomes that you're looking for. So we've moved away from building custom .NET applications that we host on EC2 instances with RDS databases. And now we build tools on Amazon Batch, Amazon Lambda, and Amazon Athena, Amazon SageMaker. So we've just decided to embrace all of these serverless technologies for us to help our customers because a lot of times we're the ones paying for this infrastructure to then make those recommendations to our customers. But at other times, customers would like these tools to run in their environment as well. So we'd rather not increase their cost by introducing a cost savings and analysis tool. And then what are some lessons learned around all of this data? And the first one is summarized basically as garbage in, garbage out. If you throw data at any machine learning service or algorithm, it will give you an answer. But if that answer means anything really depends on what data you fed into it. Machine learning is a tool that needs to be leveraged inside of a larger process. It doesn't necessarily do your work for you. It's just a tool to add to your tool bag in addition to all of the other tools you're already using. And the emphasis should always be, what are those business outcomes that you're trying to drive? The more data you have, the better. If you get into cloud, data just starts getting generated. And that's why we really wanted to highlight that bill example. But as I mentioned earlier, it's the same thing with CloudWatch. So CloudWatch and your Amazon bill are basically free data for learning just by going into the cloud. And now, with SageMaker and all of these tools, we're not so much worried about what are the mechanisms of getting GPU-based servers to then run training jobs, or how do we orchestrate this from this. It's just, what is your data, and how do you get your data into a place that you can run these algorithms on? And the same challenges that we had anywhere in development occur in machine learning as well. For example, in Amazon SageMaker, I had tried to upgrade some of the code to Python 3.6, but there was a MATLAB library that wasn't supported past, I believe, Python 3.4. So, even though I'm working in SageMaker, I'm still working with dependency management headaches, because that's just the nature of development. But I'm not worried about, is the server that I'm running on vulnerable to some SSL exploit? I don't even think about challenges like that anymore when I'm working on platforms like this. And having services like Athena are critical for that data preparation and ingestion. And if you don't have a data lake or a data warehouse, that's the place to start on your machine learning journey. Do you have time series data? Do you have natural language data? Do you have image data? OK, let's get it all in one place, because then we're going to be able to do things with it with all of these tools that are available. And then finally, if you perform shallow learning, which is really just take a data set and just curve fit, you'll begin getting the data that you need to run deep learning analysis. And that's really the next phase of all of this, is how do we run unsupervised deep learning to give us new insights for things that we never even thought about looking at. But the only way to get there is to have that data in somewhere that you can train against. So with that, we wanted to open it up for questions, and I do want to thank everybody for your attentiveness.
Are there any questions in the audience? If you just raise your hand.
Do you want to ask questions? Yeah.
Oh, we have one over here. I'll just give you the microphone.
Thank you. I'm going to admit that I'm not a machine learning expert. In fact, most of my ML training comes from the Google Developers Machine Learning series. I've gotten to episode 5, so that's where I'm coming from. In your machine learning, if you're in the example that you gave about the cost analysis and things like that, does it account for traffic, like if you have like an elastic load balancer, like for example, the 4th of July falls on a Wednesday. On most Wednesdays, I would expect there to be normal traffic flow, but on the 4th of July, there might not be. Is the machine learning smart enough to know, hey, this is a federal holiday, I should expect a lower and not ding you, or does it still alert that you then have to say, oh, no, this is OK?
So with this, it's important to have, so this is multi-years of data, so it's comparing, in a sense, year over year, but what it's actually doing is trying to fit the curve. So it doesn't necessarily know what it's looking at. It just knows, here's the shape. So that's where these predictions are coming from in this specific example. But by having other dimensions of data is when you can enable deep learning to then try to get insights like that. So it really just depends on, do you have data that the machine can use to then learn about that? Because it doesn't necessarily know that a particular day is Wednesday. It just knows that there's all of these rows, and each row represents a day. So that's where we add those other dimensions of the data to then expect, is this anomaly or not? And then if you can get those in a way that you can run against a deep learning algorithm, then you could have those insights.
And I think to add to that, you don't want to train your model using the same data set. I think that's where you want to use multiple iterations. If you have that, 100 million rows in your data set, you don't want to use the first 60 million all the time to train your data set. You want multiple iteration where you changing your data of that 60% is not always the same 60%, but it's your windows are changing, and that would help you in you training your model better to accommodate for some of those anomalies.
Thank you.
Thank you. To my observation, I'm new to machine learning. So basically, it's a trend, observation, and prediction, like what's your cost going to be. So based on that, can this machine learning principle can be applied to other aspects than just cost prediction, like weather or medical sciences or geological sciences?
Absolutely. And, oh, go ahead. I was just going to mention that this is just one algorithm within Amazon SageMaker. So this is the linear learner regressor algorithm, but there's lots of other algorithms and other hyperparameters on algorithms to make different types of analysis. So depending on what data you have will then determine which algorithm you should use for machine learning. So in this specific example, linear learners are really good for time series data. So you could theoretically look at rainfall over time, but it depends on what those data points look like each day. Because maybe with a weather model, you'd want to run a prediction. Does the model think it's going to rain today as a binary classification instead of some type of trend? So if you just wanted a will it rain or will it not, there's also a way you can run a linear learner on that. And if you had historical evidence or historical data around whether it rained or not, you could run it through it. I'm not sure how accurate predicting the weather in that way would be, but you could certainly do it and you'd get results. But there may be other algorithms available that are more appropriate depending on the data set.
What were some of the indicators that you didn't have enough data, and what were some of the challenges in compiling more data or grabbing more data and adding data sets to your model?
Really, the flow that we've just gotten into a groove on is, do we have it in Athena? And did somebody ask us a question that we couldn't get the data to answer that question from Athena? And that's been the process that we've really followed. And that's why we're also bringing like CloudWatch metrics into Athena. And that added some added level of granularity of, we're looking at cost, but we want to add a dimension now of utilization. So that's where that comes from of, cost data is cost data. So you get data for every hour, for every resource. And that's the, most granular you'll ever get today in AWS. But then those other data sets are really just question driven. And then we'll go out and collect those from things like CloudWatch. But then for customers, usually their data is somewhere in some system. And that's where we have those tools to get data out of databases and into ways that can be read by these other systems. So does that help?
Yeah, that's good. Thanks.
And I think, again, so some of the examples of that is that, for example, we had this reserved instances data, so especially if you're using a partial upfront model, on the first of the month, you'll see a spike in your cost data, which is related to the partial upfront cost, so you have to accommodate for something like that. But the recommendation would be that you start your model with simple model with a smaller number of variables, and then start increasing those variables so that your model can start learning from itself as it evolves. Okay, any other questions?
All right, everybody
right.
go start a SageMaker notebook tonight.
Yes.
That's your homework.
Thank you very much. Thanks for your time.
Thank you.